Exponent test review. When you have repeating bases, the same letter written down more than once, that's how you know that you need to expand your problem. So I've got 8 A's on the top and 3 A's on the bottom. Now when you have the same letter on top and bottom of a fraction bar, they will cancel each other out. So I do this until I run out of letters on one side. Well, what I have remaining is 1, 2, 3, 4, 5 A's being multiplied together, which is a to the 5th. On the bottom, I didn't have anything remaining, so I put a 1. And anything divided by 1 is still just itself. So whenever you have a 1 on the bottom of your fraction, you can get rid of it. For example 2, I have a negative exponent, but I do not have a fraction. So let's turn this problem into a fraction by putting it over 1. So then now I can tell, okay, this is negative on the top part of the fraction, so I need to move it down to the bottom, and now it's a positive 5. There's nothing remaining on the top, so I put a 1. When it's nothing on the top, you have to put the 1. Number 3 is similar, but this one has a negative exponent and it already has a fraction. The 1 would still be on the top, it's not going to move, but y to the negative 7th is negative on the bottom, so let's move it up to the top, and now it's a positive 7y. There's nothing remaining on the bottom, so there's an imaginary 1 there, and if I completely simplify this problem, it's really y to the 7th, and that's it. Problem number 4. When you've got negative exponents and 0 exponents, the first thing that you need to think about is moving things around. I see c to the 0 power. I'm going to mark it out because that equals 1 and I don't need it anymore. The 5 does not have an exponent, so it stays up there at the top. The a is negative on the top, so let's move it down to the bottom where it can be positive. It's negative for a b on the bottom with the negative 3, so let's move it up to the top and change it to a positive. Now I don't need to expand any of my letters right here because I only have 2 different bases, a and b. No repeating bases, so I am finished. But when you look down at number 5, that one definitely does have repeating bases. There's no negatives, so I don't need to move that around first, but I am going to go ahead and expand all of my exponents. A down here and b cubed. Now, whenever there is not an exponent after your letter, that means a to the first power. So now I've got the same letters on top and bottom. I'm going to cross them out. 1a goes away and 3 b's go away. So when I'm doing this problem, the a is on the top, so I'm going to make sure I leave it on the top. I've got 1, 2, 3, 4, 5 b's on the top, so I have b to the 5th on the top. There's nothing remaining on the bottom, so I'm going to put a 1, which we know doesn't really need to be there. So my answer is a b to the 5th power. Now this problem up here, I've got a couple things going on. First thing that I notice, though, is that I have 2 coefficients, or 2 big numbers out in front. Well, when you have that, this is really telling me the problem 2 divided by 10. When I hit enter, that gives me a decimal, so I'm going to turn it back to a fraction, which is 1/5. So I'm going to put 1 over 5. I took care of that. I do have negative exponents here, so before I can do anything else, let's move some stuff around. That one moves up or moves down. This b can stay where it was because it was already positive. That a squared can stay down there because it was positive, and b to the negative 5 needs to move up, so now it can be positive. I know I've got to expand this problem because I've got the b's written down more than once and the a's written down more than once. So 1b to the 5th, b to the 4th, over 5a to the 4th, and a squared. Now I don't have the same letter on top and bottom of my fraction bar, so I can't cancel anything out, but I can put this all back together. So I'm just not going to write the 1 just because I don't think it's necessary, but you can leave it there if you want to. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 b's, so b to the 9th power. On the bottom, I still have the 5, and I've got 6 a's, so a to the 6th power. Okay. Number 7 is very similar. When you look at this problem, the first thing I see is a to the 0. I'm going to mark that guy out. b cubed can stay where it is. A to the negative 3 needs to move up so it can be positive, and this b stays where it is. So take care of zeros and negative exponents first. Then if you have the same letter written down more than once, that's how you know you need to expand your problem. So I've got a cubed and b cubed over b. I only have 1 letter in common on top and bottom. I'm going to mark those out and put whatever I have left. I've got 3a's, which is a cubed, and 2b's, which is b squared. There's nothing on the bottom, but remember, you do not necessarily need that 1 when it's on the bottom, so this would be our final answer. Okay. Number 8. I've got a bunch of the same bases, x, x, and x. But if you look, I do have a negative exponent, so let's move some stuff around first. That one stays, x to the 4th stays because they were already positive, but this guy was negative on the bottom, so let's move it up. And that gives me x to the positive 3 power. So now I've got repeating bases. Let's expand it. X squared, x cubed, over x to the 4th. And I can cancel out anything that they have in common. There goes 2 x's, there goes 2 more x's, so I'm only left with 1 x on the top and nothing on the bottom, so my answer is just x. Now when you get to the number 9, this one is the power to a power rule. I've got something with exponents being raised to something with another exponent. So I'm going to take care of that outside one first. That thing is telling me that I need to repeat whatever is inside my parentheses 4 times. So I've got a cubed b 4 times. Now I know that I've got repeating bases now, so I need to expand it some more. A cubed b, a cubed b, a cubed b, and a cubed b. So all I need to do now is count up how many a's I have. 3, 6, 9, 12, so a to the 12th power, and 1, 2, 3, 4 b's, so b to the 4th. All right. On the back, this one is another one that does have that number, the outside exponent, so let's go ahead and repeat this problem 3 times. Now what's different about this problem is that now I have those leading coefficients. Well guys, this is one giant multiplication problem, so in order to take care of those 2's, I am just going to multiply all 3 of them together. So 2 times 2 times 2, which is 8. So this gives me 8 in the front. I have repeating bases, so I'm going to go ahead and expand this. I've got x to the 4th power and y squared, so I'm going to go ahead and expand that 3 times. They are not on opposite sides of a fraction bar, so I'm not canceling anything out, but I am counting them up. 4, 8, 12 x's, so x to the 12th, 2, 4, 6 y's, so y to the 6th power. It is the same type of problem on number 11, but this time I am dealing with a negative in front, but that's okay. So I've got negative 4. Just going to stop real fast. I have x to the 0 in this problem, so I can mark it out and save myself some extra trouble. So I'm going to go ahead and expand this twice, negative 4y cubed. Now a lot of people at this point are tempted to turn this in fraction and move things around, but this is a negative big number, a coefficient, not a little exponent, so it does not move. What I'm doing right here is multiplying negative 4 times negative 4, and if you need to do that in your calculator, that's fine. That gives you a positive 16. So I've got 16y cubed, that's 3y's, and another y cubed, 3y's. So altogether, I've got 16y to the 6th power. Number 12. I don't see any negative exponents, but I do see a 0 exponent, so let's cross that guy out. Now, when I look at this problem, I've got 5 times 8. I've got those big numbers, the coefficients out in front. When they're on that same line together, they're just being multiplied together. So 5 times 8 gives me 40. And it looks like I do have the same letter written down more than once, so I need to go ahead and expand the problem. So here's x to the 5th and then y to the 5th. Can't cancel anything, but I can combine all of my y's. I've got 1, 2, 3, 4, 5, 6, 7, 8 y's, so y to the 8th power, and I've got 5 x's, so x to the 5th. Now, it might be better to actually write your answer as 40, x to the 5th, y to the 8th, because we normally want to have our letters in alphabetical order, but if you put it like this, I am not going to count anything off. Okay. So now for the word problems. Remember that when you're talking about the area formula, and this one is for a rectangle, that's base times height. It is the same thing as length times width. So when they said, what is the area of a rectangle with a length of 10x squared and a width of 2x? So I've got a length of 10x squared, a width of 2x. Well, I know that the area formula is base times height, so the base of that rectangle is 10x squared, And the height of that rectangle is 2x. Well, I'm not doing anything with the a over there on the left. That's just going to be standing for area. But this I'm multiplying just like the problems we already did. 10 times 2 gives me 20. I've got x squared and another x. So altogether, I've got 20x cubed. Okay, last one. What is the area of a square, so we're talking about base times height, with a side length of 8y to the fourth? Well, remember that when you're dealing with a square, all of the sides are the same. So now when I'm thinking, okay, area is equal to the base times the height, my base is 8y to the fourth, and my height is also 8y to the fourth. So now I just need to multiply these two things together. I've got 8 times 8, which is 64. I've got y to the fourth and another y to the fourth, which means I really have 64y to the 8th power.